Hello, it's Keith here, and this is lesson 56 of the platform-specific series of my 68,000 assembly programming tutorials. Now, what we're doing today is we're using the Genesis, and we are adding music, interrupter-driven timed music, to our previous graphical example. We've got our min-tile example on the screen here. This is a previous graphical example. We've added music to it today. Now, what we're going to do is we're going to look at how we can enable an interrupt timed off the VBlank, and that's going to control the speed of our music. We're also going to look at my ChibiTracks multi-platform music player, just in case it's useful to you. So let's go over to our source code and let's check it out. So this is the file we are looking at today, gen min-tile sprite with sound. That's the sound file example. We're not going to look at the graphics routines. They've been covered in a previous tutorial. Please search for min-tile and Genesis on YouTube. You should find it. And so what we're going to look at today is the new code relating to interrupts. So there's a couple of things we need to do for our interrupts. Now, the address of our interrupt handler needs to be in the header of our ROM cartridge. So the VBlank interrupt, or VSync interrupt if you prefer, is IRQ level 6. That's the interrupt number that it is sort of defined as. Now we need to have the vector, the address of the interrupt handler, at a memory address 778 in hexadecimal at the start of our ROM cartridge at this position here. So I've just put the address interrupt handler here, and you can see the interrupt handler here. It's very straightforward. We're just backing up all our registers, running ChibiTracks play, which is my music player's update routine, and then finally, if I just get it on screen here, we've got an RTE, return from exception command. Now this basically pops the flags off the stack, things like that, so we need to use that rather than an RTS command to end our interrupt handler. But that's basically all it takes to have the interrupt handler executing, and of course we, as I say, we need to have that in our header in the correct memory address, but there is a little bit more that we need to do to get the interrupts to fire. So there's two things we need to do. Firstly, we need to set the interrupt level within the flags of the service register here. So we've got the SR register here. This is the flags register. And so what we're doing here with this AND-I is we're basically clearing all these interrupt level flags here, setting the interrupt level to 0, which would actually work. Basically, we need the interrupt level to be at least 6. If it's 7, the interrupt will not fire. So if I just change this bit to a 1 here, and I run my example again here, we have the sound of silence here. We can use any number below the interrupt level that we are wanting to execute. So we're on interrupt level 6. So 4 will work, 0 will work, 6 itself will work, 5 will work. What won't work though is 7. So that's 4, that works fine, and 6 works fine as well. So as I say, that's what we're doing here. We are basically clearing the interrupt level, and then we're resetting it back to 6 because we don't need it to be any lower. It shouldn't cause any problems. We've got dummy interrupt handlers for the other levels, but you know, for safety, shall we say, I'm putting it to the minimum that we require here, which is level 6. So now we've got our interrupt handler in place. We've got the processor set up to respond to the interrupts, but we do need to set the video hardware to actually cause the interrupt. Now, the way we need to do this is we need to change one of the VDP registers, and it's register 1, denoted by this nibble of 1 here. The 8 at the top of this word here, that denotes that we're changing a register. The 1 is the register number, and then we've got the value 64 here. Now, it's actually the bit 5, the equivalent of hexadecimal 20 here, that we need to set for the VBlank flag. Now, if I change this from a 6 here to a 4 and I run again, once again we have no sound. We're now, as I say, we've got the hardware ready to receive the interrupt, but we've got no interrupts being generated by the video hardware, which is doing the VBlank interrupt. So I'm doing the setting of the VDP register here. You could also do it in the bottom of the code here if you preferred. I thought it was better to actually turn it on at the exact time that we wanted it rather than anywhere else. So that's how we can set up our that's how we do our interrupts, and that's an example interrupt handler. So now what we're going to do is we're just going to quickly discuss ChibiTracks, my music player. It's a multi-platform music player. It's available on the Z80, 6502, 68000. And the clever thing, if there's anything clever about it, the thing I think is clever about it is that it can play the same binary file on all of those systems. So you write your song once, you export your song as a binary once, and it plays back in roughly the same way on all the systems. So here's the song file. This is a song that was originally written in Arcos Tracker for the Chibi Akima's game. I converted it from Arcos Tracker to my ChibiTracker Pro, and then I exported it as a binary file for today's music player. So here is the binary song file. There's a platform-specific driver which is comically called ChibiSound Pro that handles the particulars of this system and makes it work in the common way for the music player. The music player is called ChibiTracks, and there's some modules that are included there for the player. So that's all of the code for the player. The player does need a little bit of memory. It needs about 256 bytes of memory for the 68,000 systems, 128 for the 6502 and Z80 ones. A little bit more for the 68,000 though, because the addresses are longer, that kind of thing. So we're defining the address of the memory here, and we are setting some pointers up to some of the variables for the code there. Now, when we want to actually get our song ready to play, there's a couple of things we need to do. We need to, at the very start of our program, run ChibiSound Pro init. We only need to do that once. That sets up the platform-specific sound driver that does anything that's needed on that system. We're then loading in the address of the song that we want to play into songbase, the variable songbase in the music player. We then run start song. This is the Chibi tracker will then load in the parameters from the song's binary file, things like the address, the pointers to the instrument addresses within the binary file, things like that. Now we're actually overriding the song speed here. The default song speed is 5, but this song was written for a 50 Hz system, and today's system is 60 Hz, so it's a little bit faster. So we're slowing the song down a little bit to compensate, so that will slow the song down. So that's getting our song ready to play, and then the only other thing we need to do is run the play routine at regular intervals to update the actual music and change the underlying hardware to make it play the new notes as required, and that's what the ChibiTracks play does. So that's all it is to it. Very nice, straightforward thing on the most of these 68,000 systems. So yeah, as I say, just 3 things you need to remember, and you just need to do all 3 of them for interrupts. The first one, as I say, is put the vector in the header of your cartridge. The second one is make sure you have the interrupt level in the SR register set correctly. And then the third one is set up the video hardware to generate the interrupter that you are using. And there we go. So as I always say, go to my website, download the source code and the build scripts, and you can have a go with this. And as I do always say, you're welcome to use it in anything, even if it's commercial. I don't really think these examples are of an advanced enough level to be useful, but I want to make sure that you are aware you can make all the benefit of them. You can do so. If you liked what you saw today, please stick around, because this was the graphic example today was Mintile. I've now got a more advanced version called Maxtile, which does X and Y flip. It does some simulated transparency, it does fast fill, things like that, and it does it in a common way on all the systems, all the Z80, 6502 and 68,000 systems. So hopefully you will stick around for that, and you'll see a nicer graphical example. I'm quite pleased with it anyway. I hope you've enjoyed what you've seen today. Thanks for watching, and goodbye.